Okay, so let's have quick recap of whatever we have discussed. In the last session, we discussed about mapper, reducer, shuffle, and sort. We also discussed about writing the pseudo code, and then we also discussed like how to write the actual code. We also talked about a few of the internals of Hadoop MapReduce, how mapper works, how reducer works. Right. Okay, so I have got few questions to ask. The first question is, anyone remembers what is a partitioner class and what it does?
Yeah, partitioner class uh, uh, divides the key of mapper, and there is a code which decides which keys will go into which partitioner, and
Mhm. Which
like
reducer, right?
yeah, sorry, yeah, which it is.
Yeah, that's perfectly correct. So just moving on with our initial example of finding the maximum temperature. This is how things look like. Suppose we have got a file here. This is the output of mapper, and the final is the input to the reducer. Okay. So this is the file. This is the map output, and this is the input to the reducer. So this is reduce input. In this case, I have created two reducers. You can see. So this is the first reducer. Let us call it R1, and this is it. It means it has index 0, and this is reducer R2. This means it has index 1. So indexing starts from 0. So what happens in between mapper output and reducer input, there is a phase called as shuffle and sort. So this is the shuffle and sort. So shuffle and sort decides like where a particular output key is going to get, in which reducer output key and associated values are going as input. And this is a duty of the partitioner to decide which key will go to which reducer. In our example, I have given a basic example like all the even keys go to the first reducer, and all the odd keys like 1901 it is an odd number. This goes to the second reducer. We can customize this also. In order to customize, we have to use a class called as partitioner class. So we have to extend this partitioner class, and partitioner class is responsible to decide which reducer will get which key. So it takes three inputs. One is the key, one is the type of what is the type of value, and how many number of reducers are there. So these are the three inputs which this partitioner class is going to get, and it will return an integer. It will return integer, and this integer will be the index of the reducer where that particular key will go. Now my use is, I want to have two reducers. This is the problem statement, and all the keys of 1900, that is all the data of 1900 should go to first reducer, that is reducer at index 0, and other keys which are not 1900 should go to the reducer at index 1, that is the second reducer. So this is the use. How to implement this? In the same example which we discussed, this is the code. I have created one new class, maxtemp partitioner. This is the name of my own class, and it is extending partitioner. In my case, the output key of map was int writable. It was year, and the output value was the temperature that was corresponding to that particular year, and that was also int writable. So this is the input key, output key of mapper, and this is the output type of mapper. It has got a method called as get partition. So we have overridden this method get partition. It takes three inputs: the key, value, and a number of reducers. I guess a few people have joined recently, so just a quick recap on this. So my requirement is, this is the file, this is the output of map, this is the input to reduce, and in between shuffle and sort is there. And it is a duty of the partitioner to decide which reducer is going to take which key and its associated set of values. So in the we have to implement a custom partitioner. We will have to extend this class. This is a partitioner class. We have to extend this class, and it has got a method called get partition. So it will take key as the input, it will take the value as the input, and it will take number of reducers as input, and it will return me an integer. That integer is the index of the reducer to which this particular key will go. This is the key which will go to a particular reducer. So our requirement is, we are having two reducers, we should be having two reducers, and all the data of this particular year, that is 1900, should go to first reducer, and all the data where year part, that is which is the key part, is not 1900, should go to the second reducer, that is reducer at index 1. So we have written the code for this. We have created a partitioner named as maxtemp partitioner, and it is extending partitioner. This is the input key type, this is the input value type, and basically these are the output key and value types of the map method. The method is get partition. It will take the key, it will take value, it will take number of reducers, and if key is equal to 1900, it will return 0, else it will return 1. So this is our logic. So that's a very basic functionality which it is performing. And in production situations also, you may also face similar situations to create a custom partitioner. So it is very easy to make. So once you have made a custom partitioner, you would also like to register it. That is how the job will know which partitioner to use. So we can specify here. You can specify set partitioner class. So I am uncommenting this. It was earlier also, but it was not. It was commented. So I am specifying which class to use for partitioning the keys into reducers. And this is one method which is self-explanatory, that if I want to specify the number of reduce tasks. In the last example, yesterday we saw that there was a single reduce task. Now I can set the number of reduce tasks to be 0. So sorry, 2. That is, in this case, 2 reducers will be called. So these are the changes I have made. And quickly I'll make a jar and try to deploy this.
Amit, one question I have.
Yeah.
In the input to these classes you are giving, right, int writable and all. So what are the other options we can give? Int writable, string also we can give and all.
String is not there. Text is there. You can use text.
Okay. So what are all the options where we can get the information? Like what are all the options we can give to class?
Okay. So basically these are the data types which Hadoop specific data types these are. So okay, you can refer the documentation of Hadoop. I'll show you also what are the various data types which you can use.
Okay. Okay.
Yeah. Like for handling integers, we have got int writable, and for handling strings, we have got text. And there are few differences in them also. I'll also tell you that. So this is my maxtemp.jar. Okay, so I will use Hadoop jar. This is the class name. Okay, if I am correct, yeah. Then the argument will be, first argument is the file. And the second argument is the location where I want to store that. So I call it max out. Okay. So if I try to run this, so that again there will be some logs. It is showing us connecting to resource manager. What is resource manager? This is something which we'll discuss today. That is the yarn and resource manager, node manager, all those.
So Amit, from this command we are trying to send the parameter to that Java project, right? Yeah.
Sorry.
I'm saying from this command, from this Hadoop command, you are trying to send the parameters to the Java project, right?
Yeah, right. This Java class. Yeah.
Okay.
And this is a Java class which contains the main method, which we can see. And this takes arguments, the string of arguments, and the first argument is my input path, and my second argument is the output path. So it has completed. Let's check what is the result of that max out for Hadoop max out. So there should be two files because we are using two reducers. So you can see there are two files, one file for every reducer. This is the output of the first reducer, which was at index 0. This is the output of the second reducer, which was at index 1. So I want to see what is the output of that output in the first file. So ideally I should see the result only for 1900 because my partitioner was behaving in such a manner that first reducer was receiving the key, which was where the year was 1900. If I try to see that, you see in the output data for only for 1900 is present, whereas in the output of the second reducer, that is the last index, last is 1, the index is 1, you will see other years apart from 1900. So for rest of the years, the result of reducer has gone to a different file, and for 1900 it has gone to a different file. So you can control your logic, you can write your own logic to decide which reducer to receive which key output of the mapper.
Amit, one thing here, there are three files got generated, right? One is the success file also, which is giving a message. So there will be a file get generated if we get a success or failure or any exception.
Exactly. So like this is success. This is a 0-byte file. So it's just a file name. It doesn't contain anything. So it's like success or failure. For example, if I try to write something like this, what to say? Suppose input underscore 1. For example, I know this file does not exist. Okay. This is the incorrect file name. It does not exist in the SDFS, and I am using this as input. So if I try to do so, let's see what happens. It should fail, and it has failed. Why? Because it says like invalid input exception. Input path does not exist. Now if I try to see the max out, okay, so max out was not created because the file did not exist. But in case your MapReduce program fails, instead of success you will get a different folder, a different file. And one thing I must mention here also is, suppose I am commenting these two lines. What these two lines do, we'll talk that later. I'm commenting these two lines, and I'm creating a fresh jar. And if I try to run this with valid parameters, it will run. Let it run. It will run, and it will produce the output or whatever was required. And we will try to run this again also. So it is running, it has run. I'm not checking the output. I'm just trying to, okay, this is the output in the Hadoop max out. If I try to run the same program with the same output directory location, if I try to run this, see what happens. It will fail because it says like file already exists exception. So the default behavior of Hadoop is, if you try to run a MapReduce program, and if the output directory already exists, so this is the output directory I specified, Hadoop/maxout. If it already exists, it will not run. So it will say output directory already exists. So this is the default behavior of the MapReduce program, because this is just to avoid any accidental overwriting of the existing file. Because a MapReduce program takes, in intense cases, it may take hours to complete, and overwriting the same file unintentionally or accidentally is not something which we want. So this is the logic behind why we do not proceed with MapReduce program if the output directory already exists. But if you want to override this feature, if you want that even if the output directory exists, delete that output directory and then create a new output directory with our fresh results. If this is our case, we can do that using this. So you can see the second argument, which is argument at index 1, is the output directory. I will take that path. So path class is used to access the particular file paths, and I will I use the configuration object to delete that output directory. Okay, so this is something, this code is trying to delete that output directory if it exists before launching the MapReduce job, and this method launches the MapReduce job in the cluster. Okay. So is this point clear?
Amit, I have one question here. Say we have in this example we have taken number of reducers as 2. So there are 2 files created in the output directory. Right. So suppose say if we have taken reducers count as 5, then 5 files will be created. Basically the number of files created in the output file is depend on this number of reducers.
Right.
Okay, so how will we decide that reducer 1 will take, say reducer 1 will go, reducer 1 will have the output of 1900 here, then other reducer will have the other output.
Right. So I want to distribute that, is it?
Yeah, basically how like Hadoop is identifying that this reducer will do this specified task or the other task.
So it is something which will return in the custom partitioner. This is the index of the reducer where we want to send our output of mapper. So this 0 means the first reducer, whichever is the first reducer, that is reducer at index 0, will get all the keys which have 1900 as 1900, which have 1900 belonging to 1900, and all the keys which are not 1900 will go to the second reducer, that is at index 1. Now if I specify here, suppose I specify 5 reducers for example, so for reducer 3rd, 4th and 5th no input will go, and that reducer will print a 0-byte files.
Oh, okay.
In this example. Okay.
Yeah. And here in the 47th line, that out.get file system conf, that delete is striked out. So is there any specific meaning for this?
This is deprecated. I mean, this was used in the older version. So that's a warning, but it has been kept in the new API of Hadoop also. So that's a warning. You can add suppress warning to remove this underline and.
Okay. Okay.
That's a warning. That's not a problem. So now it has been the underline has been removed. So it has been a strike out because this is the older method which we are using.
Can you go back with max temp portfolio where you are doing the things right now?
Sorry?
Can you please go back to the code level where you have
in the terminal?
Yeah. No. Here only in Java where you have written the code that this will go into 0 means 1900.
Yeah, partitioner. Yeah, right.
Yeah. So here we can see one thing that we extend the partitioner class, right? So in this partitioner is any default class of Hadoop or where you have written that?
Yeah, so this is a default class of Hadoop and it belongs to this package org Apache Hadoop MapReduce partitioner.
Okay, got it.
Okay, so let's move forward with other optimizations. So today we will be discussing about other optimization and other features of Hadoop, as well as we will also discuss about yarn in the last half an hour.
Amit, one question. Like you have in this MapReduce, you have shown the example of how to sort out this text file or the normal file, whatever. So, like, is there any example you can show, like, where you can sort out another kind of data rather than a text? Because, like, we can do any kind of data processing through MapReduce, right? So, in that case, how the process will work? Basically, like how the mapper will work, how it will get the offset position and all.
Exactly. Okay. So what happens is, depending this, there are two concepts. One is input split and one is record reader. So it is a duty of the record reader to provide the input key and input value to the map method. So, and this input split and record reader is taken care by input format. So input format takes care of both those things. So we have got different input formats for handling different types of files. As of now, we are studying text file. For other files, there won't be, drastic differences. There will be minor differences, like the input key will be different, input value will be different. In text input format, the input key is the byte offset, input value is the whole line. In sequence file, the input key is not byte offset. There is some specific input key, there is some specific input value. You can use your own class also for input key and value. So we will discuss all those things in later classes.
Okay.
And there could be few things like if you want to process your XML files, which is also a kind of a different file format. So in Hadoop also we can process the XML file, and it can be very easily processed using pig also. So if you use pig to process XML files, it becomes very easy, and things will come later about this also.
No, I just wanted to know regarding how we'll process through MapReduce.
Okay.
No problem.
We will discuss that. We will discuss sequence file. Yeah, we will discuss that.
Thank you.
So that is the part of, I think, like this is the last session for MapReduce. I mean, for basic MapReduce. We are having 2 more sessions for advanced MapReduce. In that, one topic is about sequence files, and we will come to know about that there.
Sure.
Amit?
Yeah. Any further queries?
Amit, this is Amol.
Yeah, Amol.
Currently for the 2 reducers, so we splitted depend upon the keys, the way you are given the keys. But the core business logic remains the same only for both the keys. Is there any way that we can split the business logic also depend and route it to the different reducers? Let's say, for example, I need a maximum temperature, so it will go to one reducer, and there may be logic to get the minimum temperature also. Is it possible that we should send to some other reducer like that?
No, different reducers doesn't mean different logic. Whether it be 1 reducer or 100 reducers, you can specify a single logic only. Okay, so every reducer, for example, this is our logic in the reduce example to get the maximum temperature. So every reducer will apply this same logic. The data can be different, but logic will remain the same.
Okay, and we can configure multiple reducers also in the same this thing. That means, let's say this logic is for maximum temperature, minimum temperature, or whatever. So another reducer will be there for another these things, and I will get all the files in same directory, like output directory.
Yeah, all the files we will get in the same directory. But as I said, like suppose here we are specifying 2 reducers. Even if you specify more reducers, the logic for every reducer will remain the same. Every reducer will work on the same logic.
Okay. No,
so
that I understood. What I was telling, like now this logic, reducer logic we return to get the maximum temperature, right?
Right.
So that is one .java file, reduce max temperature reduce.java. So I want another like minimum temperature reducer.java, and I want to configure same thing into same code. That means it should execute one after another.
No, in the same, you cannot have different reduce tasks for different operation. You have to create a new MapReduce application for that.
So for that MapReduce, even though, okay, so mapping will be same. If it is same, we can use the same Java class for the other reducers also, right?
For other reducers.
Let's say now this is what we have written. We have mapped to keys, exactly our year is the key and temperature is what our value. So exactly same mapping I want, but my reducer will be.
your requirement is different. Like many of the things will remain the same, only the reducer class is going to be different, right?
Yeah,
Yeah.
exactly.
So yeah, so again you have to create a fresh Java project. You can copy all those whatever is there, but again you can have a single reducer class, active reducer class. So you have to make changes in the reduce class.
Okay.
Yeah, but yes, a fresh MapReduce application will be required.
Amit,
Yeah.
Amit, there is something very usable part also, na? Like if a mapper is code is similar, like what we are discussing, if the mapper code is same, that processing of input file only reducer is changing. So there should be some way, either reusability or something calling from Java that we can reuse that. So something like that, it's not possible. We will have to write from very scratch, or we can reuse the mapper code.
No, see, if we talk about this reusability, suppose there's one way you can instead of having this package, you can create a new package. Like you can create a new package, and I call it min temp, okay, for minimum temperature. I'm finishing this. Now, what I will do is in the max temp, we already have this mapper and reducer class. So suppose I'm copying this. This is a driver class. So I'm creating one new class, which is called as min temp. Okay, so this is the driver class I will be using for a minimum temperature in this case. Now, this is a fresh Java project. I have not written mapper code. I've not written reducer code. Here in the set jar by class, I will use min temp. And let us call it. This is the name. Okay. So here max temp mapper. So what you can do is, while importing, you may import it here. Import, what was the package? Package was max temp, and the name of class was max temp mapper. So I'm not writing a mapper code. I'm specifying the same mapper code here. So this is the way you can reuse. But here you have to write your own reducer program for finding out the minimum. The mapper will remain the same. Maybe the partitioner, again, it is your choice to use the same partitioner. So you can reuse. That's not a problem. You can reuse. But your reducer code has to be different, and your fresh MapReduce application will be required. Is this clear?
Amit, one thing.
Like this, you can import this. Yeah.
Hello.
Yeah.
Yeah, Amit, one thing. Why can't we write the logic of same like finding the minimum or average in the same like normally in all the programming language we won't do operation. We do in the normal one program, right? All the operation we can perform in a one program. We can find maximum.
Exactly. We can do that. No problem. So how should we do that? Let's see. If we go to the reducer.
Here only we write all the logic down also, and we can find out.
Exactly. But yeah, I'll tell you one thing. But what happens is we can do that, and I'll also show you how to do that. So this was the logic to find out the maximum temperature.
Yeah.
This is the logic to find out maximum temperature, and maximum temperature for a particular key will go to the max value. This is it. Okay. Let's have one thing more. I am having int count. Count is 0, and we have got int sum, and sum is also 0. Okay, this is it. And here for every loop I will use the sum plus, that is sum is equal to sum plus value dot get, and I will use count plus plus. So what will happen by the end of this single loop, your sum will contain the total, the summation of years, summation of temperatures. Count will contain what is the number, how many values were there in this list, in the values iterable. And if we divide these two, what we will get? We will get average. We will get average temperature for that particular year. So I can also have something like double average is equal to, that could be a decimal value also. So that we are using double. So we can have something like this. This is very simple. Now, you in MapReduce we are constrained to use a single key and a single value. In this case, we will have to make something. We have to produce maximum temperature as well as average also. So we will use text for this, and I'll tell you how to use text for that. So I will use text, and I will pass max value plus I will give a delimiter, that is a tab \t, and then I will give avg. Okay, so in this way we can produce the output which will contain max value also, then there will be a tab, or you can specify a comma, any delimiter, and then there will be average. But we have to make a few more changes. The first change is now the output is a text, so here you have to specify text. Okay, because the output of reducer is an int writable and a text, so this is the output key and this is the output value.
I mean, can't we write two statements of context dot write, one below the another? Like we can write one more statement with the text and one statement with the integer.
Yeah, we can write that. Yeah, we can also do that. No problem. We can do that.
We will give input one more text also in the. Yeah, we can do that, right?
Yeah, you can do that. But that will give you the first. It will give you two records in the output. One for the average and one for the maximum temp. Yeah, you can do that. So whatever suits you, you can do that. No problem. So if I want to give a max value at first, that is also a good way. But that depends on your use case, whether you want a single record for you every year, or you can do with multiple records. And how to identify which is the max value and which is the average, you know? If you are having two records of the same year, which is for maximum temperature and which is for maximum value, which is for average. So you can have to take care of that also.
That is a programming logic. So we can do that. Basically.
Yeah, but as of now, you can perform multiple operations in the same loop.
Yeah.
So I should keep it int because we are using the int writable. So you can use that, okay? And if you want, you may also run this program. You can export this, create a jar, and run this. No problem. And like this is for average. If you want, you can go ahead and compute the minimum also if you want. So whatever logic you want to perform in the same loop, so that's up to your creativity. You can do that. So if I try to run this now, it should run, and we'll see what happens. Okay, any more curious questions?
We are asking a lot of questions, I think.
No, that is good. That is good. I mean, that is an indication that you all are, interested, and it is very good. And yes, if you are able to understand these things which I have told you, and in this session also I will be talking about combiner and other optimizations and yarn. If you are able to get this, and moreover so this is a very, very good start. And in a very short span of almost 2 weeks, a little more than that. So this much progress is very, very good. It's very well appreciated. Okay, so let's see the output now. Again, we are using two reducers and partitioners, so there will be two outputs. So I'm interested in watching the output of this, which contains the details for year 1900. So now it should contain two records as per our logic, one for maximum and one for average. You can see this. One is for maximum, one is for average. But we don't know which is maximum, which is average. Yeah. Our intuition shows that this 30 is the maximum, is this 20 is the average. But there is no way for the program to determine this. So it is a good practice to use the same values together in a single line, separated by some comma or some tab or some anything. We can do that. Okay.
Got it.
Okay. So thanks for asking this question. And okay, so I'm going to comment this out, because telling these many things in the first session is not a good idea, I guess. So this program can be used in the future also. So now let's go ahead with something called as combiner. And what it does is quite similar to its name. It combines things. First of all, let's see. We all have seen the map output, and so map output goes to the shuffle and sort, and during shuffle and sort there is some network communication, that is data gets transferred across the network from one machine to the other machine because of shuffle and sort. So combiner can help us reduce the number of data which gets shuffled and sorted. Let's see, we have to compute the maximum temperature in this particular example. So instead of sending this as the output of mapper and this as the output of mapper, how will things look like if I send 1901 and let me compute the maximum of 1901 in this machine. So 1901 has come at two places and the maximum is 22. So this is, so instead of sending two records for 1901, can we send a single record of 1901 by doing a local processing? And similarly 1901 will come from this part also, 1901. Sorry, it is 21. It is 21. So 1901 will come from this part also. So if it goes to a reducer, the new value of 1901, I mean associated values will be 1901, then 22 from the first mapper and 21 from the second mapper. We will do the logic to find out the maximum and it will give us back 1901, 22, and this is the result. So there are some operations which are commutative, which means there's A, you do some operation B, you do some operation C, you do some operation D. There are four operands or 4 data. So suppose this operation is a plus operation. If it is a plus operation, or if every operation is plus, it doesn't matter in which way you choose data. You can sum these 3 and then add A, or you can sum in any order. Or if it is a multiplication, then you can do some any order. So ordering doesn't matter. And these kinds of operations are usually called as a commutative, where if A operated with B is equal to B operated with A. So finding out maximum is also kind of a similar approach. Like we have got few data, 10, 20, 15, 18. So if you take a maximum of this, if you take a maximum of this, so the maximum of this is 20, the maximum of this is 18. Now if you take a maximum of these two, it will be 20. So it will give the same result. It doesn't matter in which data you are taking maximum of, and similarly for minimum also. Average is not commutative. Average will depend on which data you choose. That you can try out yourself also. But for maximum and minimum, there are many operations which are commutative, like addition, multiplication, or finding out maximum, minimum. So if you calculate maximum in this mapper itself before shuffle, and if you calculate maximum at this mapper itself, that is local maximum, and then if you compare the maximum in the reduce, your reduce will have less data to compute. There is 1 data, there is 2 data, so the 2 values will be there. So the efficiency of reducer will also increase. It will have to travel through less number of values. For few records it might not make much sense and much difference, but consider a situation where a file has got billions of records, and if there are similar records, so in that case the performance gain will be very much efficient. So there will be very much considerable performance gain in large number of files and large number of lines. Similarly for 1902, it is here once, in 1900 is once here, but 1900 2 is twice here. So instead of sending 2 values to shuffle and sort, if we can send 1902 and the maximum of these 2, that is 23, again less data will flow in the shuffle. So there will be a performance boost also, and in the reduce side also, this key will be 1902 and list will be 22 from here and 23 from here. So it will have less data to process, the reducer, and this will also give us some kind of performance increase. So how to do this? So you can see the logic which we have written in the reduce side to find the maximum temperature out of the list of values, same logic we will write for the combiner also. So this logic is performed by combiner. Combiner is for kind of local aggregation of finding out maximum, minimum, or something like that. So we have to choose a key which is 1901 or 1902, whatever it be, and we have to take the maximum of all the values confined to that mapper. So a combiner is also sometimes called as a local reducer, and many a times the class which is used for reduce is used for combine also. How to use that? Let's see that. In the driver class, we have to specify the combiner class. So this is how we specify. So I'm setting the combiner class as the max temp reducer. So the reducer class, which you can see, the reducer class, which contains key and list of values and finds out the maximum of that particular maximum among that particular value. The same logic will be used for combiner, but combiner will operate on every mapper before shuffle and sort. And if we try to create a jar and run this, I'm running this jar. And this combiner has got one more advantage, and the advantage is it is a possibility, like if there are two mappers, suppose this is first mapper and this is a second mapper, it is a possibility that mapper one completes earlier and mapper 2 is still running. Now shuffle and sort will not take place until all the mappers have completed. So by the time M2 is still under execution, M1 will not sit idle, it will perform the local aggregation using the combiner. So this will be more efficient solution also. I mean, it will be very much time saving as well as cost effective also. Cost effective in the sense less data will have to transfer. So this is the output. Now you will see the map input records were 10, and there is something called as combine input and output records. So these were the input records to combiner, these were the output of the combiner. So combiner has worked in this case. Earlier you can see it was not working because we were not using combiner. So earlier it was something like this: combine input records and output records 0 when we were not using combiner. This is the earlier log. And now fresh log, after we have run the fresh jar, you can see combiner is now active. It is now taking some input and output. So it is performing, it is doing some kind of optimization which we can do using the combiner. The output will not change because the logic has remained the same to find out the maximum temperature. So output will remain the same, but it will be faster for large number of files, for large number of lines. Any queries on this combiner optimization?
So Amit, in this mapper class, we are not specifying anywhere that you are using combiner. You are just writing in that configuration file that you are
in the driver class, right?
That's it.
Yeah, the driver will take care of that.
Okay, so this combiner will always, like if you want to perform the same logic, so combiner will always extend that class, reducer class, basically.
Exactly. Yeah, that's a good question. So whatever be the combiner has to extend the reducer class, because combiner also takes the key. It will take the key and it will take list of values as input. So mapper produces key value as the output. If the combiner is getting called, all the values corresponding to a particular key will be aggregated in the mapper itself before sending to combiner. So combiner has to extend the reducer class.
Okay. So it's basically the purpose is to reduce the load on reducer. That's it. Nothing else.
Yeah,
do the local processing at mapper side.
Exactly. So it will reduce the load on reducer. It will also reduce the load on the network data which flows, and it will also increase the efficiency. Like in case a particular mapper is taking longer time, and other mapper, instead of sitting idle, it can do some processing.
So in a real-time environment, normally it's a good practice to use combiner.
We must use combiner as much as we can.
Okay.
So if we are done with this, let's move forward with one more example of MapReduce. That is a very classic example called as word count. So word count example is something like this. We are having a file and this file contains some lines are there, and it could contain something like I'm writing all thing in a small. This is a file. Suppose I've taken few records. These are the lines which are contained in a file, and I want to compute how many times each word has encountered. Like you can see, this word has been encountered at, if I'm correct, it has encountered at 4 places, 4 times. Is has come at 1, 2, 3, 4 places. A has come at 1, 2, 2 places. Similarly, I want to get the count of every word. How many times a particular word has come in a particular file. File has come at 4 places. This is it. Suppose this is a very large file, and it is divided into 2 blocks. So this is the first block, and this is the second block. And assume this is again 128 MB block. The input split is also 128 MB. So the first mapper will work on this input in this data. Second mapper will work on this data. So there will be multiple mappers working in parallel and concurrently, and we have to compute the frequency of every word. Any idea on this? How the mapper should work and how the reducer should work? What should be the map code and what should be the reduce code? Any idea? Assume that words are separated by space and a new line is separated by \n character. That is a new line, traditional new line character.
Yeah, so it will divide the single line into key comma value pair. So mapper will distribute the first line like this is a file like this comma 1 and is comma 1 a comma 1. Likewise, it will go to the second line, and likewise it will divide the whole lines into single key comma value pairs.
Correct.
Yeah, and then it will pass it to the partitioner, where partitioner, according to its key value, send it to the reducer, where it will combine by sorting, and then out to the generator.
Correct. And what will be the code in reducer?
Yeah, there will be count code, like there will be for each loop that how many times this word has been came, and
correct.
To the single key associated with a common number of values, it will join the values like that.
Yeah, so it makes sense. Yeah, that's a good approach. Yeah. Anyone who has any further ideas on this? So what I guess Neeraj said this, right?
Yes.
Yeah. Thanks, Neeraj. Your answer was very good. Yeah. So I guess there could be few people who are not aware of this, but we will discuss, no problem. But anyone who knows how we can do that, or any idea what should we do, we know the objective. Any idea? Okay, so moving on with this, Neeraj, he said he had a valid point. What we will use the text input format. That is text input format. In this case, this will be the input value to the reducer for the to the mapper for the very first time. And in the mapper, we will split on the basis of space. So if you split on the basis of space, you will get an array of string. You will get a string array. We will loop through all the elements of this string array, and we will produce the first element will be this. So we will produce this comma 1 as the mapper output. For second, we will produce this is comma 1 as mapper output. For every element of this string array, because this string array has been split on the basis of it has come as a result of splitting this particular line on the basis of space. So you will get file comma 1. Similarly, for the next line, you will split this next line also on the basis of space, and you will produce the output as a comma 1, file comma 1, whatever you get one is fixed. Is this, sorry, is comma 1 and this comma 1. So this is the logic of the first mapper, logic of mapper. In the second mapper also, for this line and this line, you will produce similar outputs. So the next other mapper will have nice comma 1, file comma 1, and is comma 1. So similarly, it will also have, sorry, this comma 1 and this comma 1. Now, so similarly, I have not written all the outputs. So this is the output of first mapper. This is the output of second mapper. So what we have done is we have used the key as word, and we have used the value as 1. So this is something which we have maintained in the mapper output. In the reduce phase, what we will get is, we will get, for example, this. Let us take one key, this. You will get the input like, it is here also, it is here also, it is here also, and I have not written, it has come at 4 places. So you will get 1, comma 1, comma 1, comma 1. In whichever mapper this particular word was there, you will get in the reducer, because the duty of shuffle and sort is to make sure that one key and its list of values goes to a single reducer. That particular key can be the output of any mapper, but that particular key will go to a single reducer and associated list of values also. Similarly for is it here also, here also, here also, in the outputs of multiple mappers. So you will get is and its list of values. So you will get something like this. There could be multiple reducers also, but it is a guarantee that this particular record will go to a single reducer. This particular record will also go to a single reducer. Now it is very easy. We have to add this. Add all the values. If you add all the values, you will get this comma 4, is comma 4. So how many times a particular word has repeated in whatever mapper, you will get the final output, and this will give you the word and how many times that particular word has been observed in the whole file. So even if the size of file is 1 petabytes, you can scale up that also. You can use thousands of mappers, no problem, or maybe 10,000s of mappers also can work, and they will work in parallel, and they will give you a very quick and very fast and very dependable output. Is this clear? Is this logic clear? Word count example?
Yeah.
Okay. So let us quickly see the code also. You will practice. You can practice this on your own.
Yeah, Amit, do we have to install the Eclipse on our virtual machine?
No, it is pre-installed. So this is the word count example. Sorry. So we have got a mapper, we have got a reducer, and we have got a word count driver. So the mapper looks like this. We are taking the value, we are converting the value to a string, we are splitting on the basis of space, and we are storing the results in a words array. So we are looping through the words array, and this word is supposed to be our text output of the mapper. So we are producing this, and one is a static final variable, iteratable variable, whose value is 1, because for every key the value is 1, and that is fixed. So we are using that. And in the reduce side, we are just adding all those things. So it's quite a simple example. Like we are using a sum variable. So for all the values of this iterator, we are getting this, and we are adding this to the sum variable. Finally, we are producing the output of key and sum. So this is how it looks like. So this is how things work out here. And in the driver, so we are doing nothing new. So we are using this particular same set jar by class, output key, output value, mapper class, reducer class. So whatever we saw earlier, So we are doing the same things. Yes, the mapper class is different, the reducer class is different. Now your output is text and your output key is text, output value is int writable because that is a number of times, and output is key is the word which is a string in Java, and text we call it in Hadoop. So this is the same, which remains the same. So I'll share this code to you also so that you can have a look on this.
So here the red.java extends reducer class, okay?
Right. You can see this.
This reducer class comes by default in Hadoop, or we have to write it?
No. It comes by default, and it is there in this. This is the full name of the class.
So any need to alter or modify that file, or is it used?
This reducer class.
Yes.
You may modify, that's not a problem. But if you have to modify, we are trying to modify the functionality by extending it and by overriding the reduce method. So this is something we are doing. This is a kind of modification, we can say. But if you want, you can go to this file also, and you can modify there also. So since Hadoop is open source, you get the access to all the code, and you can study the code, you can modify the code whenever you want. But we don't require that. Okay, so is this clear?
Yeah.
Okay, that is great. So if it is clear, that is fine. Okay, so now let us discuss about. Okay, I'll talk something about before going to Yarn. I'll talk one important optimization, which I must say. Suppose we have got a file. So, and that file has got say this is a new line, this is a new line. So there are few lines in the file, some lines are there, and I am shading it. Suppose this particular section is for first block. This belongs to first block, for example, and this belongs to the second block. So there are two blocks, and assume that there are two input splits also. So there is input split 1, and this is input split 2, and there will be a record reader. Then there will be record reader, and then there will be to read the records. And these two things are taken care by a class called as input format. Just a second. Okay, and they will send the input to the mapper. What happens is, mapper is a class, and suppose there are two input splits, so there will be two mappers, not a problem. So mapper is anything which extends a mapper class. So mapper class has got one thing which we have seen is a map method, and this is widely used. But there are few more methods. One method is called setup, and one method is called cleanup. These are two more methods, and these are the case with reducer also. In a reducer also, reducer class has got a setup method. It has got a reduce method, which we have seen, reduce method, and then there is a cleanup method. What they do is, suppose there are two mappers for two input splits. This is the first record, second record, third, fourth. I'm just giving index to give you an idea. It's like that, 8 records. So first 4 records will go to the first mappers, and the last 4 records are going to the second mapper. Setup method is called once for every mapper. So setup method will be called here, whatever is the content. Similarly, setup method will be called here also, and these things will work in parallel. Map method will then be called for every input key and value. So record reader will provide the input key and value. So you can see there are the input value is the line. So 1, 2, 3, 4. So this map method will be called 4 times. First time it will be called with the offset of 0 and whatever is the line value. Second time it will be called with a different offset, because whatever is the length of the line, and then so offset and then will be some value. So it will be called 4 times. And finally your cleanup will be called. And these things will work in parallel also. By the time map method is getting called here, here also map method will be called, here also map method will be called. Okay, so it will be called here also 1 2 3 4. It will be called 4 times. Here also it was called 4 times. And finally cleanup was called. Usually we don't require this setup and cleanup. This is defined in mapper and they do not do anything special usually. But as a part of optimization, we can do what we can do is, suppose you are reading from a database. For example, I'm giving you an example. So there is a database which is relational database, and you are reading from this. So there is one mapper, there is one more, there are 2 mappers reading from the database. So there are few things which should be done only once for every mapper, like creating a connection. So it is not a good idea that to read a particular line or read a record from database, you will create the connection every time. So you have to create the connection, then read, create the connection, then read, create, then read. No, it is a good thing that you create something first, create a connection first, and then keep on reading with every in the loop. Similarly, here also create the connection with database once and then keep on reading this. This is something which is done in Scoop. Scoop is a tool which we will discuss by the end. It will take, maybe after 2 months, but it is used to read something from a database or write something to a database. So the setup method does this, creating a connection with a database, and then the map method will either read from database or write to database. Whatever is the logic of the map, it will do that. Similar, so now we are not concerned with databases right now, but what we can do is we can see something important. Let us try to see this particular code. Coming back to the maximum temperature example. Let us try to comment this out, the output value. I'm just commenting this out. And I am writing context dot write. I have to write two outputs. The output was year 2 and temp array 1. Okay, so this is the output value, temp array 1. Okay, so the output value is say new int write table temp array 1, and the output key is new int write table. This is the output key. So sorry, this is the output key which we have seen in the logic. Okay. Oh, sorry, integer dot parseInt I forgot to use. Okay. I'm parsing that and I'm setting it. Okay, so this will also work. This will also work. So what we are doing, we are producing the year part. The year 2 means the exact year, and temp array 1 means the exact value, the exact temperature. So we are providing this as key and we are providing this as value. This is also int writable. This is also int writable. But the problem is something different. We are producing this in map method, and let us see what happens in a map. We have already seen this map method is called multiple times. So we are having less number of records here. Suppose we are having 10 million records. 10 million means 1 crore. So that's a large number of records. So suppose first input split has got 5 million records, and second has also got 5 million records. And this is something which is common in big data. I mean, this is a small number. So the first mapper, this map will be called 50 lakh times. That is 5 million times. What does this mean? If you are creating a new object inside the map method, so that will be created this much amount of times. We can see that. What is this? New int writable means we are creating a new object inside the map method, and we are creating not one but two. So see, this is one new object, and this is one object. So we are creating two objects, which means if the particular map runs for 5 million times, you will be having 10 million objects. And where will they stay? They will stay in the JVM, that is Java Virtual Machine. So I mean, mapper needs an environment to run, and that environment is provided by JVM. Those having a very basic understanding of Java must know what a JVM is. So JVM has also got a concept of garbage collection. That is, if an object is less used, if there is no reference maintained, and if it's not used, so it is collected. But this garbage collection does not run that frequently, as frequently your map runs. So map method will run very fast. The garbage collection may not keep a match with that. So it is a possibility that your mapper will require large number of RAM. How you can optimize that? You should try to minimize the creation of objects inside map method. Try to create as much as less object inside map method. If you have to create some object, either create that particular to the specific class or create in the setup method, whatever objects you want to create. And there are few questions like some people ask, like if we have got a string in Java, why do we have text in Java? If we have got integer is a class in Java, why do we have int writable in Java? So there are similarly in Hadoop, why do we have this in Hadoop, text in Hadoop or int writable in Hadoop instead of going with this Java classes? Why can't we go? We can go ahead, and we won't discuss that, but we can go ahead. We should not go ahead. Why? Because this is not optimized. We will discuss more about serialization and deserialization in the later on, but one difference I will tell you now. There are few more differences which we will be covering later. One difference is these are mutable classes, immutable classes. They cannot immutable, which means suppose you create a string and call it str is equal to hi, okay, and if you do something like str plus hello, so you cannot use, so this will create an object in heap. So heap is a space in memory, and it will store hi. If you do something, it will not make the change to the object. It will rather create a new object, whatever you want. So your hi object is also there, and hi hello is also there. So there are two string objects. So whatever you have, whatever is the value of the string object, you cannot modify the value. If you try to modify, like if you try to make a substring, or if you try to append, then you will get a new string object. There are workarounds, like if you know Java, you know there is a class called string builder, string buffer is also there, that are mutable, but they have got their own set of limitations. But in what happens in Hadoop, this text is this is the important difference, sometimes asked in interviews also. This is mutable. So suppose text, you have created a text object using new text. So this is how you create text. T is equal to new text. Suppose you have created. So you have got set method. So whatever you use set, that will be the value of this object. If you call t.set again, the existing value will be removed and new value will be used. So using a single object, so you will be creating a single object, and that single object will take multiple values at different point of time. Sometimes it may store ABC, later point of time this ABC will be removed and it may store some other value, maybe say PQR. So the same object can store different values at different points of time. A new object will not be created every time. That is the reason why we do not use this approach. I have commented this out. We use this approach. You see, before map, I have created two objects, one for output key and one for output value. So they won't be created every time. So they will be created only once for every mapper. So if there are two mappers, so these two objects will be created twice only, once for every mapper. And then I'm using this set method. So set method will give them a fresh value. This object will contain a fresh value. So new objects will not be created. These are mutable. Their inner content will be changed. The object will occupy the same space. Is this optimization clear? So you should try to minimize the use of object creation. You should try to create as less as possible objects inside a map method, and a similar functionality is for reduce also. Reduce also has got setup, reduce, and cleanup. So try to create as less objects as possible inside the reduce method. If you have to create something, try to create that in setup, or you have to make a connection to database, try to use that in setup. That will be far much efficient. Yeah, any queries on this optimization?
So Amit, in this setup, like once you do a setup, so it will create the object. So if there are 5 million objects we have to create, that won't be created in the memory, you meant to say, right?
Like if we have the set of requirements of 5 million objects, so that is for that setup might not be a good fit, but that depends on use case also. We should, for example, here there is an string object. Okay, so we have to create that, so we cannot avoid this situation. So there are few things which I mean, even if we don't want, we have to create that. But there are few situations where we can avoid the use of, for example, like this I said, this is not a good programming practice. You have to use a different situation. So try to minimize. Sometimes it becomes a necessity to create an object inside map method. We should go ahead with that if it is a necessity.
Okay. Otherwise, you have to create outside the map method, basically.
Yeah, right. As far as possible, that is the better approach.
Okay.
Yeah.
Yeah. One more thing. What is key in that map method? The first argument, long right table key.
Long right. This key is the byte offset of the line.
Okay, like 0, 1.
Yeah. Any byte. I mean, the particular line is the value. The line starts with at which byte index. That is the and I have now we will talk about yarn for next 10-15 minutes. So if you have any further queries, we can take up after this yarn session, okay, because that is very important. Okay, so if you have any queries, please keep it with you. And it is a good practice that if you attend the sessions with a paper and with a copy and a pen, so I mean there is no harm. You can keep on writing things, so whatever you think you should note it down. So that becomes I mean, if that suits you, you can use that. You can use that approach. Now let's talk about yarn. So any MapReduce application requires few things. Sorry. Before we start, let us say this is a Hadoop cluster having lots of machines, having thousands of machines, and that's quite possible. That's quite realistic. Having thousands of machines is quite real. Okay. It has got a large number of machines, and this is a cluster. Now, some user has written a MapReduce program, and this user one has deployed the program. The MapReduce is running in the cluster. At the same time, so this is a job one, MapReduce job one. A different user has written one other program, MapReduce program, and it is running on this cluster. So there could be multiple MapReduce jobs running in the cluster. There could be multiple users, or it is a possibility that user 1 has launched 2 MapReduce programs. This is also a possibility, J3. So there could be multiple MapReduce programs. So let us call them as J4, J5, J6, and whatever is that. What will happen is your cluster, which job will run at which machines. Moreover, suppose there are cluster has got resources, and when we talk about resources, 2 important things are there. One is how much RAM size is there and how much RAM is occupied of a machine. For every machine, how much RAM is occupied, how much RAM is available. And the second important thing is CPU cores. So every machine has got its CPU cores, and CPU is required for processing, or whatever your logic you write, that has to be processed by CPU. So these are the 2 important resources. So what is the availability of CPU cores and what is the availability of RAM for every machine? So this is very important to start any job. Suppose J1, J2, J3, these jobs are running and they are very much resource intensive. So they are taking lots of RAM, they are taking lots of CPU cycles. What will happen to J4? Will it get launched or not? If it gets launched, where should it get launched? What will happen to J5? What will happen to J6? So do these jobs need to wait before J1, J2, J3 completes, or when will they get launched? So there is one activity which is important, and that is called scheduling. How to schedule a job. And there are various algorithms. We won't talk about that. There is an algorithm like a sharing algorithm is there, like fair scheduler. In that case, if J1, J2, J3 are running, then the resources which they occupy will be reduced and few resources will be given to J4. This is called fair scheduler. There is a kind of FIFO scheduler, like whatever comes first will get processed first. Like if J1 comes, J2, J3, if they are running and there is no resource available, then J4, J5, J6 will have to wait for their completion. So there is some scheduling mechanism to how to schedule a job. The second is, if a job is running, say J1 is running, whether it is running fast or slow. Let us talk about J1. Suppose there are 3 mappers running on different machines. So this is machine where mapper 1 is running, where mapper 2 and mapper 3 is running. Suppose mapper 1, M1 got completed, M2 got completed, or M1 and M2 are running very fast. Okay, so and M3 is running very slow. So the mapper M3 has either not started, or it is hanged, or it is running very slow, and M1, M2 are running very fast. So what Hadoop does is a duplicate copy, whatever on the data on which M3 is running on the same data, it will launch a new mapper program called as M3 dash, or any new identity. So M3 and M3 dash will be working on the same data. Why? Because M3 was running slow. And out of these 2 mappers, whichever mapper completes first, suppose this completes first, so its result will be taken and the other mapper will be killed. So this is one optimization which Hadoop has to launch a duplicate mapper on a different machine if a particular mapper is running very slow. This is called speculative execution, and this also forms a very prevalent interview question. This is called speculative execution. What it does is, now in order to perform a speculative execution, you have to constantly monitor your jobs. This is called monitoring, because if you do not monitor your jobs, how will you come to know which job is running fast or which job is running slow? So there are 2 things. One is scheduling, one is monitoring. And in scheduling also, I would like to add this point also, like resource allocation, like how to schedule a job, which job will run first, which job will run second, and which job is going to take how much space. So this is also one third point, that is called resource allocation. So these are the three properties or features which we do not usually care as a developer. This is taken care by Hadoop also, Hadoop only. But these three things are maintained by an entity whose name is job tracker. This was in Hadoop 1. So before we learn about Hadoop 2, it is important to know what was there in Hadoop 1. So in Hadoop 1, this was the responsibility of job tracker to keep these things, to perform these three operations: scheduling of the jobs, monitoring of each job, and resource allocation to the jobs. Resource allocation means RAM and CPU cores, which job is going to take which much amount of RAM and CPU cores. This is the same thing. Monitoring means which job is running fast, not only jobs, which mapper of every job and which reducer of every job is running fast or slow, so that it can take a speculative execution. Now it is very much understandable to note that if I should come here. Suppose if there is a file and it has got 3 blocks and there are 3 input splits. Suppose this is block 1 B1, this is block B2, this is block B3 at 3 different machines. So it will be good if we launch M1 here, if we launch second mapper here, and if we launch third mapper here. Assume that number of blocks is equal to number of input splits, which is equal to 3. Assume this. This is a very valid assumption in most of the cases. So your mapper should run as close to data. This is something we discussed yesterday also, that if your mapper does not run as close to the data, data has to be brought to that mapper to process. This is called data locality. Your mapper should run as local to the data. So this thing is also taken care by the job tracker. So it takes care of a speculative execution, and while scheduling a job, it schedules the mapper at the locations where the exact block is present. And resource allocation also takes place in a similar fashion. So these are the 3 things. Please don't forget these 3 things. Try to remember: scheduling, monitoring, and resource allocation. These things are done by the job tracker. Now let us come to the problem. The problem is with job tracker. The problem with job tracker is the same which was the problem with if you watch cricket, with the problem with MS Dhoni few time back. He was the captain of Test cricket team. He was the captain of T20. He was the captain of ODI team as well. And he always used to complain that we are having less of free time. We are having very busy schedule with the cricket. So similarly, job tracker also has got these 3. It has got lots of duty to perform, because with thousands of MapReduce jobs running, job tracker, it becomes very difficult for job tracker to keep pace with all these 3 things, because it has to do scheduling, monitoring, resource allocation, everything to the job tracker. And there's no backup also. Like we have got some kind of housekeeping activity for name node is done by secondary name node, but for job tracker there is nothing called as that backup. And what happens is I'm talking little more about job tracker. There is one machine where job tracker runs, and on every other machine where the mapper or reducer runs, there is one more daemon called as task tracker. So job tracker is the master, and task tracker is a kind of slave. So every task tracker gives update to the job tracker that, see, my machine has got this much resource, my machine is running this job, this mapper has completed this much percentage. So job tracker accumulates results from every task tracker and takes decisions based on that. So task tracker run on every machine, and they send the updates of that particular machine to the job tracker. Now what happens in Hadoop 2 is, Hadoop 2 has got a concept of yarn. That is, we will have Kohli as the captain of test team, we will have Dhoni as the captain of ODI team. Let's give let's maintain a balance between different set of activities. Similarly, so what yarn does is, for monitoring of particular job, we will have a different component, and for scheduling of the job, scheduling as well as resource allocation, these are quite related. For scheduling and resource allocation, we will have a different component. So we will see how it works. But before that, with this thing in place, Yarn can support. Yarn was there in Hadoop 2, that is Hadoop version 2. Yarn can support, has got 2 or 3 important benefits as compared to job tracker. The first benefit is it can scale up to 10,000 nodes. So your cluster can have 10,000 machines as of now. It has been tested with Yarn. Whereas with job tracker, the scalability was limited to 4,000 nodes. And suppose if every node is equivalent to 10 mappers, that is one machine can run multiple mappers, that's not a problem. So it means 40,000 task. Task means either a map task or reduce task. But with 10,000 nodes, you can scale up to 1 lakhs of task, a map task or a reduce task. And the second important activity with Yarn is the job tracker supported only MapReduce. It supports only MapReduce. It supports MapReduce as well as other. So what is a MapReduce? MapReduce is basically a programming model. It is a programming practice, like how your program should be written, how mappers work, how reducers work. So that's not the only one programming model. So apart from MapReduce, there are other frameworks. There are frameworks which is one of them is a Spark, which we will discuss in the end of the session. I mean, in the end of the course, which works on worker executor model. Then there is Taze. Taze is also a developing framework. So these are the emerging frameworks which have emerged in last few years. So these are emerging frameworks. MapReduce is there. It is stable and it is widely used. But these are also emerging ones, and these are also useful in few use cases, in few scenarios. So it can support MapReduce and it can support other processing framework, other programming frameworks also. So Yarn is now a necessity if you want to run your multiple things, like if you want to run Spark, if you want to run MapReduce, Taze, so or any new emerging framework which will emerge in future. So Yarn has got the support for that also. So this is the major difference between job tracker and Yarn. I'll take 5 more minutes and I'll discuss about how Yarn works. It's very, very basic. It's very, very simple. If we have understood all those things, we will learn about Yarn. So for scheduling, Yarn has got a scheduler which takes care of scheduling, and we won't go much into that. For resource allocation, it has got 2 things. One is the master component called as resource manager, and one is the slave component called as node manager. Node manager will run on every machine, and resource manager will run, there's a global resource manager, so there's a single resource manager. And for monitoring and task execution, it has got application master. Let's see how they work together and how things work. What happens is, suppose there are few machines. This is machine 1, this is machine 2. There could be multiple machines. And suppose this is one more machine. So this is the resource manager. First of all, if your MapReduce job, MR job, is submitted to the, it will connect to the resource manager. And on every machine, there is a node manager. So node manager will send the report to the resource manager on a regular basis, that this machine has got 80% CPU consumed, 50% RAM consumed, these things like, okay, this machine has got 10% CPU consumed and 10% of RAM is getting consumed. This machine has got 100% CPU consumed and 100% RAM consumed. So what is the status of every machine? This node manager tells to the resource manager on a very periodic basis in a signal called as heartbeat. Okay, so there's signals to the resource manager. Now whenever a MapReduce job is submitted to the resource manager will check which node is good. I mean, you can see this node is not suitable because it is already occupied in a larger manner. So this is not suitable to start any MapReduce job here. So it will check, like it will make a decision like, okay, this machine M1 is fine, this machine M2 is fine, we can choose. M2 looks much better. So it will direct the machine M2 to start the MapReduce job, And this starts first of all application master. As we discussed, application master is used for, so this is a scheduling and resource management, resource manager. Now application master, it is basically the MapReduce job. It will get started on the M2. Now it will compute like how many mappers are required, how many reducers are required, where our mapper should run, where our reducer should run. Obviously mapper should run taking into the account of data locality. Like if my first block is at M1, then my first mapper should run at M1, my second mapper should run at M2. So these are the things. So it will tell its requirements to the resource manager. It will tell to resource manager, boss, I need 4 mappers, I need 6 reducers, or whatever is that, I need these things. And usually the number of reducers is less. So to make it more authentic, let's make it like I need 1 reducer, and my first mapper, it should run at machine M1 or M3 because they contain the block. My second mapper should run at M2 or M3. So these things it will tell. Now resource manager will check, okay, it requires first mapper. The first mapper requires M1 or M3. Suppose this is M3. It will check M3 is not suitable because M3 is occupied. Okay, launch it at M1. So the first mapper will launch at M1. Okay, what is the second mapper? M2 and M3. M3 is not suitable. So let us launch it at M2. So it will launch it at M2. Similarly, this resource manager will allocate the resources, RAM and CPU to the mappers. Now this mapper will communicate with the application master because through resource manager, and this mapper will also communicate with the application master. Now it is a duty of the application master to keep a progress of mapper, whether the mapper is running fine or not. If the mapper is not running fine, so it will tell the resource manager, boss, my mapper is not running fine, I need one duplicate copy of mapper called as a speculative execution. So it will communicate with the resource manager, and this particular thing is called a negotiation. You are always asking the resource manager to give you resources. So but this has got, resource manager is not now, it is not now worried, it doesn't matter, it is now not concerned with the progress of mapper 1 or mapper 2. Let the application master track the progress and track the monitoring. So these things take place in the yarn. And once that they get completed, application master will tell the resource manager, now you can delete the memory which your mapper was using. You can relinquish you can give away the control. And one thing more thing I would like to tell finally is, in MapReduce 1 there was a concept of slot, whereas in MapReduce 2, that is in yarn, there is a concept of container. The difference between slot and container is something like, suppose you want to go and buy something. So you would like to, suppose there are 2 options. One is you go and you want to buy anything like, say, milk. Okay, so suppose there is milk, so you can buy in half a liter, that is 500 ml, or you can buy 1 liter. So there is a scale for that. Okay, something like that. You cannot buy 450 ml. It is not usually the case. But if you need only 100 ml of milk, only 100 ml, so buying the 500 ml is a solution, but it will be more optimal that if I take only 100 ml, this will be quite economical to me. This is the difference between slot and container. Slot are static and fixed size memory blocks in RAM. Containers are fine grained. Like if the slot is of the order of 100 MB, so even if you require 2 MB of RAM, you cannot get less than 100 MB. You can get 100, 200, 300 like that in MapReduce 1. That was the concept of slots. But in MapReduce version 2, application master will tell the resource manager, I need only 2 MB of RAM. So resource manager will allocate 2 MB of RAM in any of the machines. So this is very much fine grained, and it is very much effective and efficient also in case multiple jobs are running. So this was about yarn. Any questions?
Okay, do resource manager and application manager falls under master slave hierarchy?
Correct. Exactly. So the node manager, resource manager also is a kind of master. Node manager is the slave. Application master also is a kind of master because it controls different mappers.
So there are three entities in master class. Okay, name node, resource manager, and application manager.
Exactly. Exactly.
So what is the concept of secondary name node?
That is for checkpointing activity. That also, I mean, that does not control any data node, or that doesn't communicate with our data node. That is just to help the name node for checkpointing.
What kind of checkpointing?
Oh, I guess did you attend the second session?
Yes, I am.
Okay, checkpointing means merging of the FS image and edits log.
Okay. Yeah. Sorry.
Amit, this yarn, is it a tool where we do all the settings, or like you told the architecture of yarn, what it does?
No, this is what it does. We do not have to temper this. This is a framework which is coming with any Hadoop distribution, and I will quickly show you a very quick configuration. Like
we have to just understand the concepts, what yarn does and all for an interview point.
Exactly. Yeah, exactly. So if you can see the log, every time a MapReduce job starts, you see the first line is connecting to resource manager.
Mm-hmm.
So first of all, it will connect to resource manager, then your application master will get started, and it will perform the processing of whatever processing you want to do. And one thing I want to show you finally is in the just a second, I'll get it debugging MapReduce applications. Yeah. So there is a history server. This is a syntax to start the history server, and this will help us in doing some things like. Okay, I have started the history server. Now, if I try to go to this site in my local machine, yes. So this will give me what are the jobs I ran in the past, like on this date, that is for 22nd March of 2016, that is 9:48 IST. I ran a job. This was the job ID. This was the user who ran the job, and you will see other details also. Okay, like what was the state, how many maps were launched, how many got completed, how many reducers were called. Okay, so these things are there, and this was the job ID. This was the name. Whatever we if you remember, this is the name we supplied in the driver. You know, maximum temperature. To identify our job, we specify a name like that. And this is if you click on job ID, you will get the history of like this also. Okay, these are the things. There are many things like about map, task, reduce task. You can go to tools, configure. There are many things you can explore. I don't think this will be aggregation is enabled. Okay, so this will not work. But if you go to local logs, you will see the logs for data node, for name node, and there will be logs for other resource manager, node manager as well. So if you want to give your own log, it will go to the user logs. So you can just explore these things, like every node manager log, resource manager log is maintained at this location. If you want your own log, see application, this is the application master log. So whatever log you want to print, you will get a container, like what was the log present in that container, and this is the system log. Okay, this is the whole kind of log, MR app master. That MR app master means this is the MapReduce application master. So this is not much of importance to a developer, but just to get to know that yes, how things work. This is the MapReduce application master, how to get the logs. This is a standard output which won't contain anything because we have not produced. There's a syntax called system.out.println. If you have that particular thing in your program, then whatever you write, that will go to std out. That is a standard output. In case of any error or any warning, there will be present in this. So these are the warnings, and which we usually don't care. So these things are present. So just to give you an idea how to view the logs. So So to view the logs, you have to first start this history server. Then you have to go to this particular port, that is 19888, and then you can go to job history, and you can see lots of applications which have run in the past, and then you can click and you can explore that whatever you want. So this is the web interface. So I'm sorry I took a little more time, but this was all for the day.